here in EA3. Today we're going to talk about operations with complex numbers. Tomorrow we're going to get into some more solving type things and really boost our solving skills on that one, and take our solving skills to the next level. And then Friday is a summative quiz day and purple homework due day. So that's Friday. Monday, I know I'm gonna sound like a broken record here, but Monday is going to be a Chromebook and earbuds kind of a day, because I got called yesterday and they rescheduled my doctor's appointment. They pushed it up, so now I won't be at school on Monday. So it's an earbuds and Chromebook kind of day. And then next week we'll have class on our 4 days, and then the 21st, which is not this coming Monday, but the following Monday. That's the day of your test. And I don't like giving tests on Monday, but it's a necessary evil because it's the only time we meet that week. So it's a good day filler, rather than start a new chapter and then take a week off. So it gives us a little extra review time. Okay. All right. So that'll take us through Thanksgiving. And then when we come back from Thanksgiving, we'll start with Unit 4, which is all about rational functions. Okay. All right. So we're going to take a moment here, and we're going to back up a little bit. We're going to take today, we're going to go backwards. We're going to go all the way back to Algebra 2. Okay. So back in Algebra 2, you should have learned all about imaginary numbers. Now today, we're going to deal with some complex numbers, but you should have learned all about imaginary numbers. And actually, you probably did learn about complex numbers back in Algebra 2 also. Okay. The two main ideas from those, or from Algebra 2 in terms of imaginary and complex numbers, are I squared equals -1, and I is equal to the square root of -1. Now, those are basically the same. Okay? Those are, if you square the right one, you get the left one. If you square root both sides on the left one, you get the right one. Okay? So those two concepts are basically the same. Now, if I would tell you, and the reason that we do this imaginary stuff is for something like this. I'm going to say f of x here. So this is a function. Based off of your knowledge from Algebra 2, what kind of a function is this? It graphs into a parabola, but it's a quadratic function. Okay? Right? We all agree that this is a quadratic function? Graphs into a parabola, right? Okay? So what we're doing here is, so this is a parabola, quadratic function. Okay. What's a point that this parabola goes through? 0,6? And that's the vertex, actually, right? Yeah, that's actually the vertex. So this point right here is the vertex. So it is also its y-intercept. Fast forward to last week. How many roots, solutions, answers, zeros should this function have? 2, right? Because the biggest degree is 2.
So we should have 2 roots, or 2 answers, or 2 solutions, or 2 zeros. Well, all of those lie wherever our function crosses the x-axis. Does this function cross the x-axis? No. But we still got to be able to solve it. That's where imaginary numbers come. And so in order to solve these type of things, mathematicians came up with this imaginary numbers, and they went way outside there on the imaginarium. Like Disney's, isn't it Disney's Imaginarium? I don't know. Where they got all creative and they went I for imaginary numbers. Great. The main focus for us in this class is going to be simplifying radicals that are imaginary or complex. Okay? Hold on. I feel as if, yep. See, I caramba, this slide should be there because I want to be on this slide first. Sorry about that. I apologize. I wanted to be on this slide first. Complex numbers first. I want to talk about complex numbers. Okay? So a true complex number has 2 parts. It's got a real part and it's got an imaginary part. A real number just has the real part. An imaginary number just has the imaginary part. But we can write them all as complex numbers by adding in both of those parts. So for instance, a true complex number would be like 3 plus 2i. That's a complex number. It's got a real part, the 3. It's got an imaginary part, the 2i. A real number, like 6, written in complex form, would be 6 plus 0i. And an imaginary number, like 2i, written in complex form, would be 0 plus 2i. Now, for us in this class, I just wanted you to know the difference between a real number, an imaginary number, and a complex number. Okay? In higher level mathematics classes, like trigonometry, okay, which would be the next logical step if you guys go on to further your mathematics career, everything is in complex numbers because of de Moivre's theorem, and that's just how they do it. Kind of a deal. Okay? So, but we're not getting to that part. Don't worry about that. Okay? So we got that going on. So back to this one now. So the square root of -8. This is what this is gonna be the main focus for us, is the square root of -8 and problems like it, simplifying these. Okay? So what we do, or what you should be doing, is you are going to take this and you're going to say, well, the square root of -8 is the square root of -1 times the square root of 8. Because -1 times 8 is -8. And then you got to ask yourself, does 8 have any perfect square
factors in it. Okay? Now, what's a perfect square number? Let's go through the first 20 perfect square numbers. You should write these down because they're going to be very, very helpful. This list is going to be helpful for you. What's the first perfect square number? 1, right? 1. Next one. 4. Third one. 9. Fourth one. 16. Fifth one. 25. Sixth one is 36. Seventh one is 49. Eighth one is 64. Somebody other than Nick. Ninth one. 81. 10th one. 100. That was that one, yeah. 11th one. 121. 12th one. 144. 169 for 13. 196 for 14. 15. 225. 16. Now this is where we get a little quicker. 256 for 16. 17. 289. 18. 324. 19. 361. 20. 400. So if a number on that list is a factor of a number that's inside your radical, your square root, it's got to be drawn out. Okay? So is there a number that evenly goes into 8 on that list? 4, right? 2 is not on the list. Right? So 2 is not on the list, so it's just 4. Okay? So 8 is the square root of 4 times the square root of 2. Right? So the square root of -1, that's I. The square root of 4, that's 2. And the square root of 2 is the square root of 2. Now, if a number is free on the outside, it can be multiplied with other numbers that are on the outside. If a number is still locked up, it can only get multiplied with other numbers that are still locked up. Okay? So the answer here, the final answer, the final solution here, if you will, or the simplified version, is 2i square roots of 2. So the simplified version is 2i square root of 2. And that's how those should be written. Free number, I, radical. Okay? Don't write the free number or the radical after, the free number or the I after the radical because it might confuse the. Okay? All right? Love it. Try those two. Simplify those two. So the square root of 49 would be the square root of -1 times the square root of 49. 49 is itself a perfect square. It's the square root of 7. So this one would just be 7i. Agree? 2 is already a free number. So it just comes along for the ride. Square root of -1 times the square root of 32. 32 has 16 here as a factor in it. So we could go 2, say blue,
times the square root of negative 1 times the square root of 16 times the square root of 2. And then that stays 2 because it's free. That one stays or becomes I and becomes free. This one is 4 and is free, but this old 2 that gets stuck back in there. And so we get 8I times the square root of 2 for that. Now, I draw your attention to this one because not everybody probably saw that 16 was a perfect square factor of 32. The majority of you probably saw that 4 was, correct? And that's fine. That works. I'm going to pick it up right from here. And I'm going to say that, so now I'll do this one all in orange. 2 times the square root of negative 1 times the square root of 4 times the square root of 8. Yes? But 8 is 4 in it. We just learned that on the last slide too. So this would be 2 times the square root of negative 1 times the square root of 4 times the square root of 4 times the square root of 2. And then my 2 is there. My I is there. Square root of 4 is 2. Square root of 4 is 2. And then the square root of 2 is the square root of 2. So then 2 times 2 times 2 gets me my 8. Times I gets me my 8I. Times the square root of 2 gets me my 8I square root of 2. And that's fine. That works. I've also seen people do the, factor trees or whatever, where they take 32 and they break it up into, 4 times 8, and then they break 4 up into 2 times 2. 8 is 4 times 2, and 4 is 2 times 2, and they, pairs, you circle a pair, and then one of those gets free. Totally fine, however it is that you do you. Okay? Try these two. So 10 is free. Square root of 28 should become the square root of negative 1 times the square root of 4 times the square root of 7. Because negative 1 times 4 times 7 is negative 28. So then this one becomes I. 10 stays 10. Square root of 4 becomes 2. And the square root of 7 is the square root of 7. So you should have here 20I times the square root of 7. Agree? Negative 4 is free. Square root of negative 75 is the square root of negative 1 times the square root of 25 times the square root of 3. Negative 4 is negative 4. Square root of negative 1 is I. I'm going to put negative I. Whoa. Tap the brakes. Square root of 25 is 5. And the square root of 3 is the square root of 3. So then this becomes negative 20I times the square root of 3. Agree? So, we'll take our function, our f of x function that we started with, that we graphed at the start to figure out why we need these i's, and now let's solve it. Okay? We got two options here. One, we could use the quadratic formula on it. Okay? That's an option. But because we don't have that linear just x term hanging out in there, we can just simply subtract 6 from both sides. And that would give us then x squared equals negative 6. Now what can we do with it? We can square root both sides. Okay? So the left side gives me just x. What's the first thing that I got to put
on the right side, plus or minus, okay? Because I'm taking the square root and I'm solving, which is different than what we were just doing in the last couple of slides where we were just simplifying. Because we're solving, the first thing we've got to do is plus or minus, okay? And then over here, the square root of -6, well, that would be the square root of -1 times the square root of 6. So that would just be I square root of 6, correct? Yeah. So then this is going to be plus or minus I square roots of 6. And that gives me, remembering back to last week, we needed 2 answers because our degree is 2. That gives me my 2 answers. One of them is positive I square roots of 6. The other one is negative I square roots of 6. Okay? So I still get my 2 answers.
Why is it positive?
Because we took the square root and we needed to have 2 answers. Anytime you take an even root when you're solving, you got to go plus or minus. If you're just simplifying, then we're just considering it to be the primary root, which is the positive one. Okay? With that being said, you solve this equation. All right, so very first thing that I have to do is what? Say louder. Either get 0 on the left side or get 0 on the right side. It doesn't matter which side you get. Okay, right? I like to have a positive on my squared terms, so I'm going to subtract 4x from both sides. And at the same time, I'm going to add 4. Because then that gives me x squared minus 4x plus 13 equals 0. Now, if we were at this very moment last week, what would have we done? We would have tried to factor this one. Okay? And is it factorable? No, because there's nothing that multiplies together to be 13 and adds to be 4. Okay? So we can't factor it. So if we can't factor it, what can we do? Quadratic formula. Okay? So the quadratic formula says that x here is going to be equal to the opposite of b, which is positive 4, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Negative 4 squared. 16. 4 times 1 times 13. 52. Okay. 16 minus 52. Negative 36. So this simplifies to be 4 plus or minus the square root of negative 36 all over 2. Square root of negative 36. 6i, right? So this is 4 plus or minus 6i all over 2. My numbers, 4, 6, and 2, do they have a common factor? 2, right? Okay. 4 divided by 2 is 2. 6 divided by 2 is 3. 2 divided by 2 is 1. So my result, my answer, my solutions, my roots, my zeros are 2 plus 3i and 2 minus. and I needed to get 2 of them because it was a square. Okay? Sure. This isn't the Pythagorean theorem, though. This is the quadratic formula.
Sorry, I was thinking about physics.
Yes.
Wrong class.
But yes, you should also. At this point in time, those should be second nature to you. Yes. Okay? That's all I got for you today. You have the remaining 13 minutes or so to be working on your homework or whatever it is that you need to do. Lots of people in the earlier class were working on their corrections for their from their formative last week.